All right. Thank you, everyone, for coming to my session instead of Facebook's session. um, so today I'm going to talk to you about a project that I've been working on since 2011. And basically, it's a mobile context instrumentation framework that is available for Android. And so my name is Denzil Ferreira, and those are my website and my Twitter link and my email. And my work is actually funded by the Academy of Finland and the University of Oulu. That's where I'm hosted. So I'm a bit different from previous speakers because I'm more linked to research and academia than properly industry. So I will talk about why we built this platform, why is it interesting actually for this conference, and what it is composed of, both the client side as well as the server side, and a few use cases in which we use this platform. Then I'm going to show you a little bit about how we actually use it in code. I will give you some live demo, and then I'll just wrap it up, and then we have some questions and answers. Okay. So because I'm an academic, I will give you a little bit of a history lesson here. So in the 1970s, people were used to have a lot of people using just one device. People would allocate time with these big computers that would occupy this whole room. And then 20 years later, we have the personal time where you could actually afford one of these computers at home. And this was around 1990s, and you would have your own personal computer. And nowadays, we are in the mobile stage. And you have multiple devices. You have your laptop, you have your computer at home, you have your phone, you have your tablet, you have your Android watch or whatever. And we are thinking that in the future, you actually will be sharing resources with others. So we're thinking about public displays, the computers that are out there that anyone can just take over and use it as their own. And then when they leave, the computer goes back to a state that you can then take over. So basically, we're kind of like going back a bit to the mainframe time, but in this case, multiple people can use the same device and other devices. You can see a bit of this also nowadays on tablets, where you can have one tablet that has multiple users in there, and you can just switch between the two, or even a computer. So another thing that has happened from a personal experience is that I have a background in software engineering and then human-computer interaction, and then I did my PhD in ubiquitous computing. And I moved to Finland to do this PhD, where actually we have, where I live, we have a highly instrumented city. So there's public displays everywhere, there's traffic sensors, there's intelligent green lights, so you're biking, you don't need to get out of your bike to press the button to get the green light. It will use radar to know that someone is coming, and it will change the light to green for you so that you don't have to stop, and things like that. So that was great for me because like I basically did my PhD involved in all of this sensor network that I could take advantage of. So like I said, my mindset also changed. So before, as a software engineer, I would just code first and then ask the questions later. So I will just deal with the bugs later. And then with the human-computer interaction, basically, I would try to get the requirements right and then do the code. And this is basically how industry normally does it. So you just make sure that you have everything pinned down into the most excruciating detail, and then you do the development. And then you have the ubiquitous computing side of me, where I always have a lot of questions and I always have to code. And this got me thinking about what Steve Ballmer said in the presentation before, which is so I don't know if you've seen this. So basically, he was just saying, we need more developers, we need code, code, code. And that got me thinking, like, okay, I don't want to spend the rest of my time doing code all the time. I'm happy this is the Android session, so no one gets offended. Anyway, so we started thinking, okay, can we build something that it's not just for developers? Can we build something that the user and even researchers like myself and application developers could use that would make their lives easier coding for Android. So you're probably thinking, oh, but isn't there other platforms that you could have used? Yes, they are. I mean, there are hundreds of them. The problem is most of them actually unmaintained. They faded out because technology keeps evolving. Mobile computing has also kept evolving. In the old days, a lot of the top ones are based on Symbian. Nokia at that time was a big player, and they would motivate a lot the sensing and creating, trying to do machine learning and doing context awareness in the mobile phones. And then more closer down, you have Aware on the bottom. So the thing about Aware is that we do not just hardware sensing, but we also do software-based sensing and human-based sensing, in the sense that we can actually ask questions to people and use that as input to your own functions. The other thing is that we also allow you to collect data centralized on your own device, so you don't actually necessarily need to send the data somewhere else. So you can do analysis on your phone, or you could distribute that between your phone and the server. The other thing is about everything that the framework produces can actually be shared for other applications. It can change dynamically on the fly, and it can also be scalable. So the platform is actually plugin based. So if you want to add new features, you just create a new plugin that adds that feature, and you're good to go. You don't need to recompile everything. So I've been talking about context, but I didn't say what context is. So from a dictionary perspective, I'm sorry, my computer is a bit slow. This is not my normal computer. My computer actually is down, so this MacBook Air is kind of weak, but anyway. So according to the dictionary, context is the circumstances that form the setting for an event. But of course, from a computer side of things, computer science side, is any information you can gather or you can use to characterize a situation of something, an entity. And an entity here can be a person, it can be a sensor, it can be a place, it can be an object, anything. So it's very broad. So in a way, what we wanted to do is, can I use the phone to somehow get a glimpse into the context in which the user is? And can I use that to make my applications better? So to give you an idea how this would work, so if we have a phone, so basically the phone has tons of sensors in them, accelerometer, whatever. But for this example, let's consider the accelerometer. So the accelerometer data is normally very noisy. So you get a lot of raw data, but then somehow you need to analyze it and process it to make it into something useful for you. So let's say that someone builds a plugin and calls that a step counter. So basically, right now you have a new functionality that your phone provides to all other applications who want to do step counting, for example. And then let's say that you have someone else who does activity recognition. So they use the step counter and they want to do activity recognition to know, for example, every time you're walking, how many steps did you actually do? Or how many steps do you do if you're running, for example? And let's say an app developer decides, okay, I'll build sports tracker and I'll just reuse these two and I'll just make a mobility application. And then let's say that you have someone from a different field, let's say medical field, diets, and they want to do calorie counts. So they probably don't have the know-how to build these classifiers to do the step counting and activity recognition. But they do know that based on how many steps a normal person does, she will consume this much amount of calories. So basically they can just package all of this into a new application and just do a diet tracking application. So the whole idea here is to make whatever output you have and the pieces that you build, you can reuse to build something bigger. So like I said, we collect data from hardware and software is things like the calendar, your email, your contacts information, things like that. Are you online or offline? And the human-based sensing is the questionnaires. I will show that later. So the idea here is we take that data, we perform analysis, and we build these plugins in which we abstract the data, the raw data, into reusable units. Those units normally are useful for people. So I don't know if you're aware of the quantified self movement. So these are individuals who strive to collect data about themselves and then learn about that. So the framework is actually quite good for that, because without any code, you can actually collect this data for yourself, and then you can see the data. As a scientist myself, I actually use this platform to do user studies, and I will show you some examples of that. And we use those mostly to validate the plugins we build, to make sure that they work the way they should work, are we getting the right data, and things like that. And as a developer, you can actually leverage this for your own application. So that means you make an application faster. So user input, we have a few functionalities. So basically, we can allow the user to write free form, and then you can analyze based on the answers they gave. You can use that for your own purposes. You can do radio boxes or check boxes. So radio just allows you one choice, multiple choice, Likert scales, linear scales we also have now. It's not there, but we do that. And also quick answers, so things like, are you in the bus right now? Yes, no, things like that. So like I said, the idea here is we want to use all of this data and reuse it as much as we can. So Aware kind of packages all of this data and abstracted data into 3 different things. So broadcasts, these are native Android broadcasts, content observers. So you can observe into a database and you can query the data as it's being collected, or you can just query it yourself by accessing the content providers. So the content providers are just databases. And the idea here is to share, monitor, and store the data. So in terms of infrastructure, so the bottom side you have the client, and the client within it has all the sensors you could think of. I will show you how it looks on the phone, and also the plugins that people develop. And we use those. We take the data, we store that on SQLite, and then that's shared using the broadcasts, the providers, or the observers. And then we also have the server side, which allows you to integrate what we collect on the phone with other services. So things like Google Cloud or App Engine, Amazon, Microsoft, anything. Or you can use MQTT, which is a machine-to-machine protocol developed by Intel. And it's actually open source, so you can use it. And you can do publish, subscribe between devices. So that also allows you to do this kind of thing. And you can collect data on the server side, and you could do further analysis on the server side on a much larger scale, so things more intensive to do, like predictions and things like that. So if you install the application on your phone, it looks something like this. So basically, on the first screen, you have a list of sensors that you can activate and deactivate. I will show that live soon. And the idea here is to allow anyone who wants to collect data to quickly collect that data without having to code a single line of code, okay? And the plugins is kind of like an app store within Aware itself, and it allows you to download self-contained packages that will extend what the framework does. So you have a few examples there. So the first one, ambient noise, basically turns on your microphone for 1 second every 5 minutes, so depending on what the parameter you want, and tells you if you're in a noisy or a quiet environment. Android Wear one allows me to know, for example, how much battery do I have on my watch, or allows me to query like what applications do I have right now on my watch and things like that. The device usage actually measures every time I turn on and off my screen of my phone, and actually makes a plot of that. So I can see like how often do I use my phone, for how long do I use my phone, and things like that. Activity recognition, location, light, how much light, like how much time do I spend outdoors versus indoors, and things like that. The NTP actually measures drift. So like, you know, phones, if they don't synchronize with the time server, the clock, internal clock actually drifts. We actually needed that plugin for a project that we worked on, earthquake sensing. And we needed to synchronize data between multiple devices, and the clock needed to be the same so that the data would be collected at the same instance of time. And weather. And the interface for the user It's basically very similar to Google now. So you just get a set of cards that just summarizes visually with statistics, some of them, to the user, the data that he's been collecting. So we found this very helpful, especially when we're collecting data from people, to motivate them to actually continue collecting that data for us. So that was kind of nice that we don't have to later, if we want to collect any combination of those sensors or plugins, we don't need to develop a new application. We can just choose and pick any specific combination we want, and we have the interface already done for us. So we've been using this to measure, do large-scale and geographically distributed studies, or even personal studies, so people collect the data for themselves. We allow you to, we either host the databases for you for free, or you can host it yourself. That essentially makes the client connect to your server and the data goes to your server. You can run multiple studies at the same time. You can have plugins that only the people who belong to the study actually have access to that plugin, or you can just make it public. You can specify any combination of sensors you want to collect data. You can enroll participants by just scanning a QR code or giving them a URL. The QR code is easier. Allows you to collaborate with other people. So the other thing that it allows you to do is you can share the access to the database and someone else can help you analyze the data. You can also monitor the status of the study. So basically, you can see how many people are actually sending you data, what kind of data are they sending for you. You can also label and group people, so you can do A/B testing, for example, or have a set of participants that have a specific configuration versus another one. You can remotely ask questions. So for example, if you detect something interesting on the data, you can actually ask that person specifically, like what happened on this day or something like that. Or you can actually remotely request the syncing procedure to happen or even reset the study. So sometimes, you know, when you're collecting data from people from all over the world, you might realize, oh, I forgot to collect data about this. Let me reset this thing, and you can do that. So some of the use cases we've used, we looked at battery, and we collected data from 4,000 people. Of course, these numbers are nothing in comparison, for example, to Spotify, who collects data from 75 million. But anyway, from a research perspective or academia perspective, this is actually a quite good number. We tracked people's recharging habits, like for how long do they keep the phone plugged in and stuff like that. Other things like how far do they keep their phones from themselves. Actually, they are about 50% of the time close to them. Most of the time it's just in the same room, but not necessarily on them. Another thing that we looked at was application usage. So we collected data from people on how long they keep an application actually active. And we actually found that on average it's about 15 seconds. If you think about that, you're like, oh, 15 seconds, that's quite short. And actually, we found that it actually depends on the kind of applications that people use. So in this publication, we talk about the implications that this will have if you design an application, and if you think about how people use the application, maybe it makes sense to optimize the interface to streamline these 15 seconds. Of course, it depends on where they are, if they are around someone or at the time of the day. And then with psychologists, we've been looking at addiction. So especially in young teenagers, that they seem to not be able to let go of the phone, and they feel anxious, and if they are running out of battery or they don't have network coverage, and they feel like all these emotional and psychological effects on how they behave. So actually there's a name for that. It's called nomophobia. So that's quite interesting. And the thing is, we don't know if that's actually something that is induced by yourself, or is it because of someone else. So for example, if you think about a person working in a company, they might be more stressed in these situations because they won't be able to reach him because he's at work or something like that. And then the idea here is to see, can we do something to mitigate this problem? With the Air Quality Center in Finland, we also looked at symptoms in terms of asthma. So, for example, people who have asthma, we check, does their mood change depending on the time of the year, the amount of physical activity they do, how much do they walk on a daily basis, like the mobility range, the air quality around them, and then the weather conditions, and also the symptoms that they report on a daily basis. We are currently analyzing this data. In Japan, we collected data from 1,000 people who volunteered to give us data on earthquakes. And we've actually been trying to build models to detect if the building in which the person is collapses or fire. So the idea here is actually the most deadly effects of an earthquake is actually the building collapsing or fires. It's not really the earthquake itself. So we're trying to see if we can build a crowdsourced mechanism that would be used to actually provide faster estimates of damage. So right now it takes days or even weeks for the city to even have an idea of how much of the city is actually damaged. We are trying to make this take a matter of hours or even minutes if possible. So these were all academics projects. And we also built full-fledged applications with companies. So there's the first example. I'm sorry I couldn't get the sound to work through the HDMI. You have to excuse this computer. It's a bit slow to load, apparently, the movies. All right. It's from here. So most of these features, as you could see from the phone, it's actually built on top of Gingerbread. This was done in 2011. So a lot of these features nowadays actually come with Android, like for example, rejecting with a message, and what else? Having your online status, things like that. So this was done in the context of a company who needed to improve the efficiency of their mobile sales force. And the idea here was if you're busy, your secretary would take the call. If someone calls you and you reject, you would be able to tell them why are you rejecting the call and things like that. So this was done in cooperation with a company, and it's actually been sold to Vodafone. So Vodafone in Europe is actually using this with their road warriors. That's what we call them. And this was actually basically the birth of Aware. It was within this project, and how we used multiple sources of information and aggregate them in a way that it would help you be more efficient. So things like, for example, the contact-centric communication history. So instead of searching through all your emails for someone, you know the person, so you just go to the person and you would see everything you've done with that person, calls, messages, everything, without having to search that for yourself. So another more recent project is about network security. Let's see if this doesn't take that long to load this time. Come on. All right. Anyway, I'll just continue. So basically, this allowed us to kind of build a map of hundreds of applications and where they connect to, which servers they use, is that connection encrypted or not. We did this in the context of F-Secure, so we used a Finnish security company, and we developed an application that allows them to collect data about what makes people trust a developer versus another. Are developers using SSL appropriately? Is the data really just between your phone and the server, or does it go somewhere else, and things like that. Okay, let me see if this works. Okay, now it's working. All right. Just very strange that we don't hear anything. Okay, because I had muted it. Okay. So the other thing that we did here was actually simplify the permissions. Actually, Google is doing this now. So we actually combine all the permissions that Android had into 9 of them. And the idea here was you would set the permissions that you care about and and forget about it. So basically, when you would install an application that would require these permissions, you would be notified on the fly, on the market, before you actually run the application for the first time. We also crowdsourced the ratings that other people would give to an application based on the information that we collected, and also their assessment of security. So for example, here you could see WhatsApp and the connections it's making, to where is it making, is the connection encrypted or not. And we used the IANA, which is the standard for communication ports, to know if the connection was secure or not, and then we did deep package inspection to know if the data in it was actually encrypted, because sometimes companies decide to use some random ports and then it doesn't really match to the standard encrypted ports. So the idea here was allow you to quickly glance to see, okay, where does WhatsApp have servers, to where are other people sending the data to, and this way you could build a world-wide map of applications. And then we would ask people on the fly questions about, do you trust this developer? why did you rate it this much, and things like that. And that gave us a little bit more insight into what really matters to users from a security and privacy perspective. And it also allowed us to collect data from applications that come bundled in the phone. And actually, it was funny to see Samsung sending data all the time to South Korea. So it was quite interesting. Anyway, so you got the idea of what you can actually do with Aware. So Aware is open source. We're using the Apache license. That means you can actually do commercial products with it. We don't mind. And those are the links to the website where you can actually download the source. Alternatively, you can just go to awareframework.com, and then there's a link there for this. And it's actually quite easy to use it. We actually have Aware in Gradle integrated with Maven Central. So you just put the repository there to go get the package from Maven Central, and then the dependencies. We have a dependency with app-compat because Aware is actually compatible with Gingerbread and higher, and that it's about 90-something% of the whole market right now. Then there's the Play services is only used for if you actually have your phone paired with the Android watch, and that way you can actually check the battery of your phone and stuff like that, and the watch vice versa. And the card view is used for making the cards that you saw on the interface for the user. And then the framework itself. So we do have online a lot of tutorials on how to use this thing. So instead of boring you with a lot of code, I will just direct you to the website and then check the tutorials on how to do it. But to give you an overview of how easy it is to use it, so let's say that you want to collect data from a sensor. In this specific example, which is really tiny on purpose, so that you can see there's a lot of lines of code in there. This is just activating the accelerometer data and making sure that the accelerometer data keeps on when the phone turns off, like the screen turns off. Some manufacturers actually turn it off as soon as you turn off the screen. So if you're collecting data like activity or something like that, you need to do a few workarounds so that the accelerometer stays up. And this is just that. And then if you have the component of saving data into a database and then synchronizing that data to a server, this will just go crazy. So the idea here is, okay, how can we make this easier? 4 lines of code. Once you have the library, you can just ask, activate the accelerometer, how fast you want to collect the data from the accelerometer, and this is using the same constants from Android API. So that's 200,000, that's the normal sampling rate, and then ask Aware to activate that. So this is actually consistent across all the sensors we collect data from. So all the sensors have a variable in this class, Aware preferences, where you can just turn on the status true to false, and you can find also more settings. Some sensors have more settings than others on the documentation. And to turn it off, you just do the same, but set it to false. And then you just do the broadcast to apply those settings. So like I said, we have 2 ways of actually reading the data, or after you collected the data, like how do you use it? So you can do the traditional way. A cursor, do a query, get the data. That's normal Android APIs. So in here, there's nothing else actually to do. And all the databases are actually, for every sensor, they have their own content provider, which you can take advantage of. So that means that you can not just do queries using cursors, but you can also do content observers. And that means that every time there's new data inserted into the database, your application will be notified of that. And then you can react in real time to the changes in the data. But of course, if you do this cursor just like this, you don't know, and that's why we call that passive. So you just get the latest entry or the latest 100 or whatever how you, depending on how you structured your query. And then we have the active way, so you can do, you can listen to context broadcasts. So actually the framework itself will send a broadcast every time a batch of data has been inserted into the database. So you know, okay, there's no new data in this sensor that I didn't have before, and then you can do the query, or you just do the content observer to get the data in real time and then do anything with it. So for example, doing something like this, so detecting if the user has unlocked the phone. This is something that actually Android just has the thing about screen off, but not really unlocked and locked. We actually have that built in into the framework. So you just activate the sensor for the screen, and then there's two broadcasts that are actually sent. One of them is the screen unlocked, and the other one is the screen locked. So if you just have a broadcast receive it for the unlocked event, you will get that on your application. And then if you do the context observer, you can actually do all status. So basically off, on, unlocked, relocked, protected, all of these. And it also allows you to do more analysis, because then you can actually do queries inside the context observer to go like get the data from the last day or things like that. And it's a bit more power efficient because you don't pull the data, you just get notified from your content observer. There's an example of that here. So for example, in here, there's the screen locked, unlocked, screen off, screen off. So I will give you a demo of that. So let's go there. Okay. So this is my phone. I found actually a very nice tool yesterday that allows me to control my phone from here, which is quite interesting. So so I have the Aware application, which I've opened. So this is the client. And like I said, it's meant to be as simple as possible for someone who doesn't know how to code the Android to be able to collect data. So for example, if I wanted to activate the accelerometer data, I would have pressed there, and then there's a switch there, activate, and then you can set how fast you want to sample that data. So if I would go there and activate that, there's a delay here, okay. And then if I come here, you can actually see this is the logcat of my phone. And you can see it's collecting the data and saving that on the database. And if I want to turn it off, you just press there, and it turns off the sensing. So I also mentioned that we have the plugins. So there's other, for example, more interesting sensors. For example, if we come here to the applications, there's a very interesting sensor here that actually I showed this to a security expert, and he was impressed that we could actually get this data. Actually, I need to activate the accessibility services. Give me a sec. Okay. So if I go here and I want to track, for example, keyboard usage, I could actually do that. And this is kind of scary, because basically from this moment, I can actually know what I'm actually typing on my phone anywhere. You can see here the keyboard and what I just typed, test, and which application I used it. So this was actually the Google Quick Search. But if I open, for example, a text message, and if I write a text message, I can, for example, collect data about who are you talking to and what are you saying. This, from a research perspective, this is quite interesting because you can do analysis in terms of how fast people accomplish tasks, how fast do they type, how efficient is the keyboard, and things like that. So this is just to show you how integrated the platform is. So the plugins, you can install them, like I said, through an app store that we have built in. It's right there on the left, and then there's plugins in there, and you have a few of them. So to show you just a quick demo, if I want to activate, for example, the open weather, it collects this kind of data, like when did the sun rise, sunset, and all of that. So I would just activate that. And now I will have here on the stream, so we call it a stream, so we have a summary of that data. And here you can see I've been actually collecting data since this morning, 6 a.m. And then you can see a plot of the temperature, how it rose from the night to the day, and what are the predictions for today, and amount of air pressure and all of that stuff. The other thing that we also support is the studies. So we have a dashboard, and you can actually have access to it on the api.awareframework.com. This is a web service, and you can use it to collect data and also do server-side things. And the idea here is that you can easily sync up a device that is running the client with your study just by scanning the QR code. There's actually a QR code reader on the client itself. I can show you, so it's right there. So if you press there, and then I would join the study. Let me just go back to the, I think that was a bad idea. I was pressing the wrong button. Okay, so if I would scan the QR code, I get something like this. And this comes from the server side, and then I just sign up, and basically my phone becomes a participant of this study. And it says they're joining the study, and from now on, basically my phone is collecting data for this study. You can see here, there's a notification saying thank you for joining the study, blah, blah, blah. And you can also ask questions. So for example, let me just show you that. So this is my phone in here. So if I would want to ask, how are you feeling today? And then you can just write whatever you want, and you would send that to the phone, and basically I get that on my phone, which actually is not working. Okay. Demo effect, I guess. But anyway, you can push questions to the phone. I think it's just my network that is down. Okay. So this whole infrastructure, of course, I didn't do it all by myself. And it's ongoing work, not just from me, but also a lot of people. This is a small sample of people that I interact on a daily basis. So if you use Aware and you find a bug, please report the bug, and our team will try their best to try to fix it. And that's it. I'm open for questions.
Anyone has any questions?
Did you make any test working with cars, things like OpenCX or ODF protocols?
Not really, not yet.
So I mean, if I understood correctly, it will be possible to create plugins.
Yes.
To retrieve this information from the car, right?
Yes.
Okay.
Yeah, you could use the OCDB port. Yeah. Actually, I've been thinking about doing that with my car to start collecting data also on the performance of the car. Well, especially now with this Volkswagen problem. So yeah, it would actually be interesting to see exactly what happens after they fix the cars. So yeah.
We'll talk later.
Yeah, sounds good.
Anyone else? Okay.
All
So thank you for the presentation,
you.
and see you all in 15 minutes. No, in a half hour, the next presentation.